Recording in progress.
Can you hear me, students?
Yes, madam.
Okay, thank you. So I just waited for others to join the lecture. Out of around 150 students, only 35 students have joined. I know now you are here. Anyway, let's see what are the, let's say whether we can have these lectures physically at the faculty. You know, we don't have enough space to, if you can remember, yesterday I started this section, measures of variability, and we discussed this example, right? So if we have two data sets, so how we are going to compare those two data sets, right? So I asked you to find measures of central tendency for these data sets, and you just found them. And if you can remember, for these two data sets, we got 43 as mean, median, and mode, and here also 43 or 42. Sorry, 40. 40, no? Okay. Sorry for that. Give me a second. Yes. 40 was found as mean, median, and mode. And here also 40 was the mean, median, and mode. So at that, in that case, finding measures of central tendency is not enough to compare these type of data sets if we have. Therefore, we have to go for another measures of something that is called measures of variability. Okay, so we discussed our first measure of variability, that is range. Range is defined as maximum element minus minimum element. That means difference between the maximum observation in the data list and the minimum observation of the data list. Okay, right. Then we discussed the variance and standard deviation for a ungrouped data. Okay, so I'm going to start with here the variance and standard deviation. Let's look at this example. I will explain it again briefly. So we have this data set. Okay, if you can remember, these are the data which were in data set 2 in the previous example, right? So if we have this type of data list, this is how we can find their variance or standard deviation, right? So we had two formulae. Okay, we can use this formula.
Excuse me, madam.
Yes.
Madam, screen full screen දාන්න පුළුවන්ද?
Full screen නෙවෙයි ඔයාලට පේන්නේ.
ඔඩියෝට පේන්නේ madam.
ඔඩියෝට පේන්නේ. Okay. I will. Okay, give me a second, right?
Yes, madam.
Okay. Right. I hope you all can see my screen clearly. If it is not clear, please let me know. Right. So we were discussing these two formulae, right? So we can use these two formulae to find the variance or standard deviation, right? If we want to find the variance first, right, we can use these two formulae. But if we have a data list like this, okay, if we have a data list like this, we would use the first formula. I will tell you why we use this first formula. Okay, it's really easy to use the first formula to find the population variance if we have such a data list. Okay, so first we get the difference between the element and the mean value we found. So first of all, if we have a data set and if we want to find the variance, right, we want to find the mean value first. After calculating the mean value, okay, we need to get this difference. We call this as deviation. So we are finding the deviation of mean value from each and every element in the data list. So this difference is called deviation. And if we add these deviations, finally we will get 0. Therefore, we will consider another term called square deviation. Square deviation, or xi minus x bar squared. So what you need to do is you need to find the xi minus x bar term first and get the square value. So here for the first element, the square value is what? Minus 7 squared. Then 49, 36, 16, 9, 0, 0, 4, 25, 36, 49. So we have found these square terms. After finding these square terms, we find the summation. Right? Now you have to substitute these values obtained from the table in the formula. Okay. Now look at the formula. Here we have found the mean value, right? The formula for that is sigma x over n. After finding this mean value, we found those measures xi minus x bar squared, and the value of n. So what is the value of n here? What is the value of n here? N is 10. Okay, we had only 10 elements. So substitute those measures in this formula, then you will get sigma xi minus x bar squared. That is the summation of square terms. That is 224 divided by 10 minus 1. Here you have that calculation. And finally, you will get 24.8. And if you want to find the standard deviation, you need to get the square root of 24.88. Okay, so the standard deviation would be, for this example, 4.99. Now we have found variance and the standard deviation. Now using those two measures, we are going to interpret our results. So how do you interpret the result we got? What do you mean by the variance or standard deviation? If you can remember yesterday also I explained it. Okay. Here we have found the variance as 24.8. No. Okay. That means for this data set, right, the mean was 40. Okay. Now 40 is deviated from each and every element in the data set. Okay. The 40 or the mean of the distribution of or mean of this data set is deviated from each and every element in the data list by 24.8. That is simply called variance. Or if you get the square root, we can say that standard deviation. Standard deviation. The mean has been deviated by 4.99 units from each and every element in the data list. So that is the second measure of variability. I told you yesterday also, if we want to compare two data sets, okay, we can find their measures of central tendency like mean, median, mode. Not only those measures, but also we need to calculate their measures of variability, right? Measures of variability. So first one we can calculate as a measure of variability is range. So range indicates what? It indicates the size of the data set. Then we can find their population sample variance or standard deviation. If it is a consistent data set, right? If it is a consistent data set, we need to minimize this variance. For example, tell me we have two numbers, okay? Now we have two numbers. In this data set, there are only two values. Now, what is the mean of this data set? What is the mean? Can anyone tell me the mean? 2 plus 2 divided by 2. What is the mean? That is 2. Okay, right. Give me a second. I will explain it again. I hope you can see my screen, right? Let's say we have two numbers. That means a data set of two elements or two observations, right? The mean value is for this data set is 2. Now I'm asking you to find the variance or standard deviation. So what do you think of these two measures for this data set? Variance. If you want to calculate that value, this is how we calculate it. 2, that is x. X minus x bar is what? Now x bar is 2. No? Therefore, 2 minus 2, 0. Here also 2 minus 2, 0. 0 plus 0 gives 0. If we substitute these values in the formula for variance, that is x minus x bar square divided by n minus 1. Now, what is the summation of x minus x bar square? Summation is what? 0, no? 0 divided by 2 minus 1. That is 0. Now, you can see that for this data set, okay, the mean was 2, but the variance was 0. Sorry. Right? The variance is 0 and mean is 2. So for this data set, you can see that there are only two elements of two. There are only two elements. Those two elements are 2. No? So without calculating the variance, you should know the variance of this distribution is 0. You don't need to calculate it. By looking at the data set, you should know the variance of this distribution as 0. How? You know, the deviation of the mean from each and every element of this data set is going to be 0. නේද මේ mean එකේ deviation එක මේ හැම element එකෙම 0 කියලා පේන්න තියෙනවානේ නේද ඒ හින්දා ඒක calculate කරන්න අවශ්‍ය නැහැ. You don't need to calculate that variance, but by looking at the data set you should know the variance is going to be 0 for this case. Is that clear? So we expect from every data set the variance is going to be 0. අපි expect කරන්නේ variance එක හැමතිස්සෙම බිඳුව වෙන්න. මොකද variance එක බිඳුව කරන්න පුළුවන් නම් ඇත්තටම හොඳයි. But in real scenario we cannot make it as 0, but we can decrease that value, or we can minimize that value. For example, if you take two players, okay, A and B, in cricket, yes, these days your favorite sport is cricket, no? Right? So if we take two players A and B, and if you take their scores for 10 matches, right? 10 matches. Let's say 55, 46, 98, 99. Likewise, he has scored some marks. For player B, right? Let's say he has scored 50, 55, then 60, 54. Likewise, he has got these scores. Now tell me, from A and B players, okay, from A and B players, which player is good at batting? What do you think? What do you think? What do you think? Player A or player B? What do you think? Player A or player B? Do we have enough information to say that? Okay, if you want, I can give you more values, right? Okay, let's say $96, again 0, 0, 44, and 55, 60. Now the player B has got 6, 77, 80, 95. Yes. And 0. Okay. Right. So these are the data you have. Now tell me which player is going to be the best player. Now the scores of the player A is 55, 46, 98, 99, 96, 0, 0, 44, 55, 60. Player B has scored 50, 55, 60, 54, 46, 77, 80, 95, 150, 0. Now you need to find the best player. Now tell me a method to find the best player. Now you have that knowledge. How we are going to find the best player. Now we have two data sets. The variable is same. What is the variable here? Variable is score of a match. Okay. But we have two data sets for player A and player B. Now tell me how we are going to find the best player. Best player. How we are going to find that? You can just find their mean of A and mean of B. Here I'm not going to calculate that value, okay? Let's say the mean of player A is, let's say 70. I don't know, I didn't calculate it, right? Mean A is 70 and mean B is, let's say 68. Now we have found their mean values, mean or average values. Now tell me, which player is the best player? Which player is the best player? Player A or player B? What do you think? In the examination, right, I am not going to ask you to find mean, variance, or standard deviation for these data sets. Sometimes I may ask, or I may give this kind of data sets, and then I will ask, find the best player using this data. So you should know how to find the best player. Okay, questions, you may get questions like that in the examination. So I'm not going to give you the method. You should know the method. That's why I'm teaching these basic, basic things in statistics. Okay, so we have two data sets for player A and player B, and we found their mean values. Now, by comparing these mean values, can you say the best player? Can you conclude player A is best player among these two? Hmm? Please tell me, what do you think? Huh? What do you think? As I mentioned earlier, mean comparison is not enough to compare two data sets. So we need to find the best player නේ. අපිට හොයන්න ඕන හොඳම player නේ. ඔයාගේ mean එක වැඩි බව ඇත්ත. Mean of A is greater than mean of B. This is correct. But it is not enough to say that player A is best or he is good. It's not enough to say that. Therefore, if we have their mean values, we need to go for their variances as well. Variances as well. Okay. Now, let's say we have found their variances as, actually we do not know, but let's say variance of A is variance of standard deviation. Okay, you have to find only one measure. Let's say variance of A is around 8. Variance of player B is around 5. Okay, now tell me which player is going to be the best player, player A or player B? I will summarize this data. A, B, mean, variance. Mean is 70, 68, and variance is 8 and 5. Now tell me which player is going to be the best player, player A or player B? You know about cricket more than me, better than me. Neither. Can man how the best player? 044 BST 044. I know you are here. 44 BST 1819 044. What do you think? Which player is the best player? Player A or player B? You are wasting your time, right? So tell me, hurry up. It's okay with your answer is correct or not. It's okay. Please tell me. I need your ideas. Tell me, guys. Okay, I got one answer. Player A. Okay, good. Others, what do you think? What do you think? Please tell me. Okay. If you are unable to talk to me, please send your answers through the chat. Please send your answers through the chat. Please tell me. The best player is A or B. What do you think? Okay. I got another answer from Lakshan B and 072. He says A. What else? Other students? Please tell me, students. Without knowing your answers, I cannot go forward. One is again saying B and A. Most of you are saying player A is good or better. A. Let me clear that doubt. Now we need to find the best player. Neither. අපිට හොයන්න best player. Some of you are saying player A is good. He's better than player B because his mean value is greater than 68. By looking at the table, you can just conclude player A is better than player B because his mean value is greater than mean value of player B. Therefore, we can conclude that player A is best. Okay. Now, consider their variances. If we want to find the best player, we need to consider their consistency as well. Consistency. නේද? ඒ කියන්නේ දැන් අපි තරංග 10ක් ගත්තොත් තරංග 10ම එයා ලකුණු 100ම ගැහුවොත් එයා කොහොමත් හොඳයිනේ. ඒක ප්‍රශ්නයක් නෑ. අපි හිතමු එයා තරංග 3-4කම බිඳුව අරගෙන හැබැයි අනිත් මැචස් වල එයා හොඳට ගහලා තියෙනවා 80යි 90යි 100යි 110යි එහෙම. හැබැයි තරංග 3කදී 4කදී විතර එයා 0 අවුට් වෙලා. හැබැයි තව ප්ලේයර් කෙනෙක් ඉන්නවා එයා කවදාවත් බිඳුවට අවුට් වෙලා නැහැ. හැබැයි එයා හැම මැච් එකේම අඩුම ලකුණු 40ක් 50ක් ගන්නවාම. right? දැන් මට කියන්න ඒ ප්ලේයර්ස්ලා දෙන්නගෙන් consistent කවුද? Consistent. Consistency means he or she should have a less variability. එයාගේ variability එක minimum වෙන්න ඕනේ. If he is consistent, he should have a less variability. නේද? ඒ කියන්නේ එයා හැමදාම එකම වගේ ලකුණු ගානක් ගන්නවා නම් එයා හොඳයිනේ අනිත් කෙනාට වැඩිය. එයා වේරි වෙන්නේ නැහනේ. එයා හැමදාම ලකුණු 40 40 50 ගන්නවා. හැබැයි අනිත් එක්කෙනා ලකුණු 90 100 ගහනවා. හැබැයි ගොඩක් දවස් වලට බින්දු. එතකොට මොකද වෙන්නේ? එයා වේරි වෙලා නේද එයාගේ ලකුණු අතරේ. සමහර දවසට 0 සමහර දවසට 80 90. නමුත් අනිත් ප්ලේයර් හැමදාම ලකුණු 40ක් 50ක් 60ක් ගහනවා. ඒතර ඒ දෙන්නගෙන් කන්සිස්ටන්ට් කවුද? කන්සිස්ටන්ට්. කන්සිස්ටන්ට් අර හැමදාම ලකුණු ගහන එක්කෙනානේ. තේරුණාද? අන්න ඒ වගේ මෙතනදිත් අපි කන්සිස්ටන්සි එක චෙක් කරන්න ඕන. Consistency can be checked by comparing the mean values. Usually we use measure of variability, that is variance, to check their consistency. Then mean value compare කරාම මෙයාගේ තමයි batting හොඳම කියලා හිතෙන්නේ. The player is good or better at batting if we compare their mean values. But if we compare their variances, you can see that the variance of A is greater than variance of B. variability එක වැඩි player A ගේ player B ගේ අඩුයි. Variability is high. If variability is high, which means consistency is less. Here player B, right? His variability is less. If his variability is less, that means his consistency is high. Understand? Therefore, we need to compare their variances as well to find the more consistent player. So, best player, who is the best player? Best player is the player who is more consistent. More consistent. Understand? Therefore, the best player is going to be not player A. You have to consider their variances. If you compare their variances, we can say that the player B is the most consistent player from these two, right? Therefore, the best player is going to be the player B. But I will teach you another method to find this consistency. It's not enough to find their means and variances to find the consistency. Okay, in this case, these two players has a similar average value, 70 and 68. They are really close. No? Therefore, it's enough to compare their variances to conclude their consistency. The consistency එක බලන්න variances විතරක් compare කරාම මෙතනදී ඇති. මොකද යාළුවගේ mean values ගොඩක් close නිසා. හැබැයි ඔයාලට තව ඊළඟට questions මම දෙනවා. ඒවයිදී mean එක අපි හිතමු mean of A is 75, mean of B is 40. Okay. If you compare the variances, variance of A is 6, variance of B is 5. හරිද? දැන් mean එක 75යි මෙයාගේ 40යි. මෙයාගේ variance එක 6යි මෙයාගේ 5යි. දැන් මෙතනින් කවුද best player? අපි variances compare කරොත්, if we compare their variances, we can say that player B is the best player because he has less variability. Okay. But if we compare their mean values, they have huge difference between their mean values, 75 and 40. Understand? Now you may think, no, the player is good. He is good at batting because he has average score 75. No? In that case, we need to calculate another measure that is called coefficient of variation. Coefficient of variation. We need to find that value as well if we have this type of measures of variability and measures of central tendency. Okay, I will teach you how to find this coefficient of variance. For now, please remember, if we want to compare two data sets, it's not enough to compare their mean values. We have to go for variance comparison as well. Understand? So if we want to find the best player among 2 or 3 students, 2 or 3 players, we need to find their coefficient of variation as well. We will teach you that later. For now, please remember, we need to compare their variances as well. Understand? Did you understand it, students? Did you understand it? Please tell me. Did you understand it? What the meaning of the variance? Please tell me, students. You have to respond. උච්චර ළමයි ගොඩක් වාඩි වෙලා ලෙක්චර් එක අහන් ඉන්න වෙලාවේ එක්කෙනෙකුට අද උත්තරයක් දෙන්න බැරිද? තේරුණාද නැද්ද කියලාවත්? I don't know whether you are listening to the lecture or you are doing anything else.
Yes, madam.
Okay, thank you. Right. Now, we will look at the other formula used to calculate the variance, sample variance. That is sigma x squared minus sigma x all things squared divided by n minus 1. Okay. So we can use this formula when we have a data list. Okay, without frequencies. If we have frequencies, we have to use another formula. I will discuss that later. For now, we have a data list. We can use two formulae, first one and the second one. Okay, I taught you how to use the first formula to find the variance, and now I am teaching you how to use the second formula to find the variance. Okay, right. So let's say we have data list like this: 1, 2, 3, 5, 8. Likewise, we have 5 data uh, elements. Okay, 1, 2, 3, 5, 8. First, we find sigma xi squared. Xi squared. Here xi squared. 1 squared is 1. 2 squared is 4. 3 squared is 9, 5 squared is 25, 8 squared is 64, and get the summation. Okay, 89, 98, 103. Okay, now sigma x all things square. Okay, we will substitute these values in the formula. Squared sigma xi squared is obtained as 103 minus sigma xi all things squared. You have to square the 103 and it should be divided by n. Now what is n here? 1, 2, 3, 4, 5. 5 elements. Okay, and all things, the whole part divided by n minus 1, 5 minus 1. You will get the same answer if you use the first formula. Okay, so 103 minus 103 squared divided by 5, and whole part should be divided by 5 minus 1. So if you have this type of data list, you can use this formula as well. Okay, understand? For this data list, also we can use the same formula, same equation. Finally, you should get the same answers, 24.8 and 4.99. Understand? Is that clear, guys? Okay. In this week, I will give you the first tutorial. Okay. From that tutorial, you will find some questions where we can use these two formulae to find variances or standard deviations, right? Okay. Did you understand how to apply the second equation? Yes or no? If you want to, if you want me to discuss it again, I will briefly explain those terms. Here, sigma xi squared. That means first you need to calculate x square values, then get the summation minus 1 over n. Now n is 10, sorry, n is 5 now. 1 over 5 times sigma xi whole thing squared. 103 squared, and that should be divided by n. Here we have 1 over n coefficient, and whole thing divided by n minus 1. 5 minus 1, that is 4. Okay, After simplifying this, you will get the variance. And here there's a special term, sample variance. These two formulae are used to find the sample variance. That means if we have a sample data, if we have a sample data set, we have to use these two formulae to find sample variance or sample standard deviation. Okay, if you want to find the standard deviation, you have to get the square root. Understand? But this formula will be different if we have population data. Here, what is the difference between those two formulae? Formula used in sample variance and population variance. Previously, the equation had x minus x bar. Now x bar is what? Sample mean. And here we have n, sample size, n. But in the population variance equation or population variance formula, we have only capital N, not n minus 1. Previously we had n minus 1, but here we have capital N, not n minus 1. And instead of this x bar, here we have mu. Mu is what? Population mean. So we just know if we have population data, we don't need to use sample mean. Since we know the population parameters, we can use them to find population variance. Therefore, if we have population data, right, we are going to find the population variance, not sample variance. To find the population variance, we have to use population mean. And this denominator should be capital N here, not n minus 1. Understand? So in question, sometimes you may ask to find the mean and variance for following population data. Here, it's not mentioned as sample mean or sample variance, but there's a hint in instructions. You have to find mean and variance for following population data. Population data. Yes, a hint. That means you have population data. So if you have population data, please remember, keep in your mind, you have to use this formula, sigma squared or sigma. Understand? So it depends on the data set we have. If we have a sample data set, we find sample mean. If we have a population data set, we find population mean or population variance or population standard deviation. Is that clear, guys? Is that clear? Then answer will be different, right? Sometimes if you consider the same data set as sample data, you will get same mean value, like population mean. Okay? But if you find their variance, okay, population variance may different from sample variance. Understand? Because in sample variance, we had n minus 1, but here in population variance, we have capital N. Therefore, definitely the population variance will be different from a sample variance. Is that clear, guys? Okay. Now, I will explain. If you have group data or frequency tables, how can we use these two formulae to find population variances or sample variances, right? I will teach you it now. Give me a second. Right. Let's say, I hope you can see my screen, right? X 2, 4, 6, 8. The frequencies are given as 4, 2, 3, 1. Now this is called a frequency table, right? You want to find mean and variance. Okay? You want to find mean and variance. And you are given the question like this. Find the mean and the variance for the following sample data. Okay, find the mean and the variance for the following sample data. There it mentions either we have population data or sample data. No? So in this case, we have sample data. That means we are asked to find sample mean and sample variance. Sample. You need to understand it by reading the question, whether we have sample data or population data. Okay, right. So mean can be calculated using the formula sigma fx divided by sigma f. Now what is sigma fx? You need to multiply f and x. So construct another column for fx. Fx, it is 2 times 4, 8, 4 times 2, 8, 6 times 3, 18, 8 times 1, 8. And get the summation. What is the summation? Huh? What is the summation? 8, 8, 16, 16 plus 18, 34, 34 plus 8, 42. Clear? And what is sigma f? Total frequency. 4 plus 2 plus 3 plus 1. 10. Clear? Not this equal to 10, right? Sigma f is 10. Now we will use the formula sample mean, that is equal to sigma fx divided by sigma f, and sigma fx was found as 42 and sigma f was 10. Finally, we will get 4.2. Understand? So this is the mean for sample mean for this data set. Is that clear, guys? Okay. I hope you understood how to find the sample mean. After finding the sample mean, we are going to find the sample variance or sample standard deviation. Both can be found. Okay. If the question asks sample variance, we need to find sample variance only. We don't need to find sample standard deviation. Therefore, we write the formula sample variance square. That is equal to sigma xi minus x bar squared divided by n minus 1. But if you can remember, I will show you the formula. Here it mentions Give me a second. One group data. When you have group data, the formula becomes this. Okay, I will explain it. If you have population data, then the formula is summation fi times xi minus mu squared over n. This is for population variance. So if we have sample variance, for group data, right? Group data. Group data means we have frequencies values. We write this formula as sigma fi. I goes from 1 to n, right? Fi times xi minus x bar squared divided by, instead of n minus 1, we write sigma f I goes from 1 to n minus 1. N minus 1 is replaced by sigma f minus 1. Okay, so this is the equation for group data. Sigma f x minus x bar squared divided by sigma f minus 1. If you want to find, if you want to use those indices, you can write if x I goes from 1 to n. Here also if I goes from 1 to n. Okay, so this is the formula that we are going to use to find the sample variance when we have group data. Group data. That equation is not in the presentation. Okay, if you want, you can write it down. So this formula must be used to find the sample variance. So here I wrote the formula we use to find the sample variance if we have a data list. But here we do not have a data list. No, here we have a frequency table. That means we have group data. The data grouped, right? Therefore, we need to put fi term here. Fi xi minus x bar squared divided by, instead of this n, we write sigma fi, I goes from 1 to n minus 1. Okay. Here we do not have class intervals. Here we do not have class intervals, but we have frequencies now. Okay. So we need to put these frequency values as well into this formula. Okay, that's why we changed our formula into sigma fi xi minus x bar squared divided by sigma fi minus 1. Okay, now consider the table again. I will create that table again. Here we have x, f. What are the x values? 2, 4, 6, 8. 2, 4, 6, 8. Frequencies are, particular frequencies are 4, 2, 3, 1. 4, 2, 3, 1. Okay. Now, sigma f was found as 10, and we just constructed the column f x 8, 8, 18, 8. Now we need to find xi minus x bar squared term. Therefore, we write f xi minus x bar. 2 minus, what was our mean? 4.2. 4.2. Get the value, okay? Then 4 minus 4.2. 6 minus 4.2. Finally, 8 minus 4.2. So here we have obtained our xi minus x bar values. Then you need to construct the column which contains xi minus x bar square. You have to get the square terms. Here we have 2 minus 4.2 is minus 2.2 and get the square value. Here we will have minus 0.2 and get the square value. Here we will have 6 minus 4.2 is 1.8 square. So here we have 3.8 square. Okay, now we have found xi minus x bar square column. But again, look at the formula. Here we have another term fi. Because we have frequencies now in this table. So we need to multiply this column by frequency column in order to get the numerator. Okay, so you need to construct another column. I will draw that column here. Okay, xi minus x bar squared times fi. Now multiply 4 and this value. 4 times 2, sorry. 2.2 squared. Okay, 2.2 squared. The second value is 2 times minus 0.2 squared. Minus 0.2 squared. Here you will get only positive values because this xi minus x bar square column contains only positive values. No. Therefore, when you multiply that column by frequency column, you will get only positive terms. Okay. Then 3 times 1.8 squared, 1 times 3.8 squared. After getting this column, you can simply get the summation as a value, positive value. Okay, you have to get the summation. You have to add all the square terms. Understand? Now substitute these terms in the formula. What is the formula? Sigma fi xi minus x bar squared divided by sigma fi minus 1. Because we have sample data here. Okay. Now this don't substitute sigma fi value here, right? This is not sigma fi. This is sigma fi times xi minus x bar squared. This summation is common for fi times xi minus x bar square. Not for the fi only. It's common for both terms. Therefore, substitute fi times xi minus x bar squared total sum. That is this value. You have to get the summation. Okay, this value. I don't know that value. You can use a calculator to find this value quickly. Okay, and substitute this value here and divide it by sigma fi. Now, what is sigma fi? Sigma f is 10. You know, 10 minus 1. Clear? Is that clear, guys? Yes or no? Is it clear, guys? Did you understand how to find that sample variance when we have sample data, grouped sample data? Group means actually we do not have class intervals, but we have frequencies now. So when we have frequency table, we have to include that frequency column as well into this formula. That's why we multiply this fi minus x bar square term by fi here. Okay, after finding this total uh, fi times xi minus x bar squared, we need to substitute that value in the formula here. Okay, then you can easily find the variance, sample variance. If you want to find the sample standard deviation, you need to get the square root of this value, the value you get here. Is that clear, guys? Is that clear? So if you have a frequency table with class intervals, okay, if you have a frequency table with class intervals, here you will have class intervals no? Instead of xi values. So in that case, xi must be replaced by the mid value of the class interval, of each class interval, mid value. I told you how to find the mid value of a particular class interval, right? Upper value plus lower value divided by 2. That is how we find the mid value of a class interval. Okay, so I'm not going to discuss this equation again and again. I will give you a small, not small, I will give you a tutorial from this section for you to practice. Okay, how to find sample mean, sample variance, population mean, population variance. Okay, is that clear, guys? Anyway, you need to understand if we have sample data, we need to find sample mean, sample variance, sample standard deviation. But if we have population data, you need to find population measures like population mean, variance, standard deviation. Understand? So you need to get an idea of the data we are provided, whether they are population data or sample data. Sometimes in the question, the data type may not be given as population data or sample data. In question, you may ask like, find the sample mean, sample variance. So find the population mean, population variance. Then you need to understand, here we have population data. That's why we are asked to find population mean or population variance. Like that, by reading the instructions, you should understand it. Clear? Clear, guys? Okay, now we are going to compare two data sets. Okay, two data sets with their measures of central tendency and measures of variability. Okay. So far, did you understand what we discussed? Yes or no? Did you understand how to find mean, median, mode, and variance, standard deviation? Is that clear, guys? Yes or no? Please tell me. Please tell me, guys. Okay. Before uploading the lecture note, I will include the formula when we have frequency table. Okay. to find sample variance and sample standard deviation. Okay. Right. If you don't have any question, I can start next topic. Difference between two data sets. Here actually, if you look at the first diagram, right? This diagram, this has two curves, right? But you can see only one because one coincides with other one. Therefore, you can see only one curve, but there are two curves. Now, tell me what can you say about these two data sets? Here you are given relative frequency histograms. Yeah, last week also I mentioned if we have such a graph, we call it as distribution of a particular random variable or frequency histogram or relative frequency histogram. Okay, right. Now we have two data sets, but we have only one curve here because one coincides with other. Now my question is, what can you conclude about these two data sets? Both have same shape, same measures, no? Therefore, we can say that those two sets are identical. Can you even sarva sama distributions? තේරුණාද අර කලින් ගත්ත එක්සැම්පල් එක අපි data set දෙක compare කරේ ඒ දෙක සාටම සම නැහැ. It's not identical. Why? Although they had same measures of central tendency, their measures of central tendency were 40, no? Mean was 40, median was 40, mode was 40, everything was same, similar, but when it comes to measures of variability, they were not same. Understand? They had different range values. They had different variances values. We didn't calculate their variance, but we calculate the variance of the second data set. If you calculate that value for the first data set, you would get different value, another value for variance. Okay, that means their measures of central tendency were same, but their measures of variability were not same. Therefore, those two data sets were not identical. But here we have two identical sets. There, identical sets means here measures of central tendency are same. What are the measures of central tendency? Mean, median, mode. And there are measures of variability. Measures of variability. They are also same. Variance, standard deviation, range, every measures of central tendency and measures of variability are same for the first given two distributions. Understand? That's why we say we have two identical sets. We have two identical sets. But if you consider the second diagram, here also we have same shape curves. They have same shape, no? Normally it is bell shaped and both are symmetric about their mean value or the mode value or the median value. But there's only one difference. What is the difference? What is the difference? You need to understand it by looking at the graph. Although their shapes their shapes are similar, their locations are different. Understand? How can we say their locations are different? If the location is same, then one should coincide with other. If the location is same, here the location differs. Therefore, what can we say about these two distributions? Locations differ means what? I told you. Measures of central tendency, also called as what? Measures of location. Measures of location. Locations differ means what? They are measures of central tendency are different. You can directly see that from the graph. Here, the mean lies around here for the red curve. But for the blue curve, mean is somewhere here. And that value is less than this value. You know, if a curve looks like this, it is bell-shaped, symmetric about its mean, median, and mode. Therefore, this curve is symmetric about its mean, median, mode. This curve is also symmetric about its mean, median, mode. Their shape is same, but their location is different. The blue curve has different measures of central tendency, while the other has different measures of central tendency. But they have same variance range. If you calculate their variances, you would get same variance. If you calculate their range values, you would get same range values because both curves are similar, no? But their location is different. Their measures of central tendency are different. Is that clear, guys? When you do researchers surveys, you may need this knowledge. Okay, if you have different data sets to compare, you should use this knowledge. Okay, without calculating those measures, you should say about the distributions by looking at the relative frequency histograms of those distributions, right? So you don't need to calculate those values. If you look at the relative frequency histogram of particular data sets, you can say there are differences. Okay, you can just compare their values. In previous example, that finding the best player, in that case also, if we have their relative frequency histograms, then we would easily tell about the best player by looking at their relative frequency histogram. Unfortunately, we didn't had their distributions. No, we had only their scores of 10 measures. So looking at those 10 measures, if we want to find the best player, then we needed to consider their mean and variances. But here, if you look at this diagram shows every measure of central tendency and measure of variability. Okay, now consider this third diagram. What can you say about these two data sets? Actually, it is given, the conclusion. Variabilities differ. What happens here? The location is same. The location is same, no? Because both curves are symmetric around its mean, median, and mode. Both curves are symmetric about its mean, median, mode. that means their mean values, median values, mode values are same. That's why we call their measures of central tendency are same, or their location is same. They had same location, no? Starting value, ending value, the mean, median, mode, all are same. But there's only one difference. What is that? Their variability. Their variability. Look at the shape. Their shape is different. No? Location is same, but the shape is different. Here, the red curve, it has a less variability or high variability. What do you think? What do you think? Variability? Variability is less. In blue curve, variability is high. So if you have such a relative frequency histogram like this, it has a high variability. Okay. Is that clear, guys? Variability එක අඩුයි වැඩි කියන්නේ මොකද්ද? ඒකේ අදහස තේරුම් ගන්න. Variability එක අඩු නම් මොකද වෙන්නේ? මම කිව්ව consistent වෙන්න එපා. Variability එක අඩු නම් variability එක වැඩි නම් එයා consistent නැහැ. දැන් variability එක මෙයාගේ අඩු නිසා තමයි ගොඩාක් values එයාගේ mean එක ළඟ තියෙන්නේ. Most of the points are around its mean, median and mode. Therefore, in this red curve, we can see that a less variability. Variability is very less. But if you consider this curve, it has the high variability. High variability. Understand? Okay, you will understand that again in the fourth diagram. Here, you have two curves, red one and blue one. What can you say about these two data sets? These two distributions? Locations are different, of course. This red color one is symmetric about this value, and blue color curve is symmetric about this value. Okay? Therefore, location is different. Locations differ. If you consider their shape of the distribution, shape is also different. No? They have different shapes. Blue one. This has less variability, not less variability. Compared to this one, this has high variability. This is less variability. This is high variability. But in real scenario, if we can have such a distribution like blue one, actually it's better. Compared to this one, this has high variability. But if we can get this type of a curve for any distribution, which means that distribution is better for statistical analysis. Okay. So in this fourth diagram, you can see that both locations and variabilities are different. Is that clear, guys? Is that clear? Let's say we have these two data sets. And this one. What can we say about this three distributions? Actually, this should be a straight line, vertical line, okay? That should be perpendicular to the x-axis. Anyway, these three curves are symmetric about about their mean, median, mode, because they have different shapes, but their location is same. They have same location. Therefore, their measures of central tendency are same. But if you look at their variability, this is actually good. The middle one is really good. But compared to this one, it has less variability. This is actually average value, right? Average variability. This has high variability. Okay. Understand? Usually we expect from data set a middle one, the normal distribution. Last week also I mentioned about normal distributions, right? So if we have symmetric bell shaped for a particular distribution, we call it as a normal distribution. And if we calculate their mean value and variance, using that mean value and the variance, we can say about the distribution of the data set. Okay, I will let you know those things later. For now, if we can have such a graph, such a shape for a particular distribution, we can say that that distribution or that data set is normal. Okay. In chapter 4 or 5, we will discuss those things. Okay, for now, please remember how to compare two data sets using their measures of central tendency and measures of variability. Okay, please do not omit these parts, do not neglect these parts. In the examination, definitely you will be asked questions from from this section to compare two or three data sets using these measures. Okay, therefore don't neglect these parts. Right, so far we discussed how to compare two data sets using the measures of central tendency and measures of variability. That is the fundamental way to compare two data sets. There are more methods. Okay, we will discuss those methods at the end of this course, right? Finally, we will summarize all the methods. For now, remember how to compare two data sets, two or three data sets. Okay, now there's another important measure, that is relative position of data. Now read this small paragraph. When you take an exam, what is often as important as your actual value score on the exam is the way your score compares to other students' performance. For example, if you made 70 but the average score was 85, then you did it relatively poor. If you made 70 but the average score was 55, then you did relatively well. Right. Now, suppose you are a student of statistics class. Okay. In that statistics class, there are, let's say, 20 students. Now your score is 70. 70. You have scored 70 out of 100. Now, can we say you are a good student? Without considering your score, because you have made 70. No? 70 is an average value. What can we say about the person who has got 70? Is it a good student or bad student? I mean, regarding the score of a particular exam. Okay. What can you say? Actually, 70 score is not enough to give a conclusion because we need to consider the average score of that class. නේද? අනිත් ළමයි ගත්ත ලකුණු තෝරන්න වෙනවනේ අපිට 70 ගැන කියන්න නම්. Without knowing others' scores, how can we say the person or the student who has got 70 out of 100 is good or bad? Good or poor? How can we say? That means we should know the other scores as well. So if the average score of that class, of that particular class is 85, average එක දැන් 85යි. අනිත් අයගේ ඔක්කොගේම ලකුණු ටික බැලුවොත් average value එක 85යි. Compared to that 85 value, 70 is relatively poor or better. What do you think? Compared to 85, 70 is poor. 85ත් එක්ක compare කරාම 70 කියන්නේ very poor value එකක් නේද? But the average score of the class is 55, then what would you say about 70? Compared to 55, 70 is good. It's relatively good, relatively well. Therefore, it's really important to know the position of the data set. So we call this as relative position. With compared to other values, what is the my position or what is the position of a particular data element, sample element. Is that clear? Understand? So we call this as a relative position of data. In general, the significance of one observed value in a data set strongly depends on how that value compares to other observed value in a data set. Okay, I will tell you a small story about a person. Can a person class sport meet එක තියලා මොනවාද කියන්නේ මේ කවපෙත්ත විසි කරලා දෙවනියා. ඉතින් ගෙදර ඇවිල්ලා කිව්වා දැන් මම කවපෙත්ත විසි කරලා දෙවනියා වුණා කියලා. හරි සතුටු වුණා අම්මයි තාත්තයි ගෙදර අය හැමෝම ඒක දෙවනිය වුණා කියන්නේ අනරත් වෙනවා කියන්නේ හොඳයිනේ ඉතින්. ඔයාලා මොකද හිතන්නේ? දෙවනිය වෙන එක හොඳයිනේ ඉතින් නේද? එනකොට කම්පිටිටර්ස්ලා කී දෙනෙක් හිටියද කියලා ඔයාලා දන්නවද? දෙන්න ඉඳලා තියෙන්නේ. එතකොට එයා දෙවෙනිය වෙච්ච එක හොඳද? එයා දෙවෙනිය වෙච්ච එක හොඳයි. නමුත් හිටියේම දෙන්නයි කියන්නේ අන්තිමයනේ. නේද? එයා හිටපු ගාන කියන්නේ නැතුව එයා දෙවෙනිය වුණා කියලා කිව්වා. ඉතින් හරි සතුටු වුණා හැමෝම. නමුත් ඉඳලා තියෙන්නේ දෙන්නයි කියන්නේ අන්තිමයා. මං කියන්නේ එහෙම වෙන්නේ හොඳ නැහැ කියන එක නෙමෙයි. අන්තිමේකුත් ඉන්න ඕනේ නැත්තම් පළවෙනි ඉංග්‍රී වෙන්නේ නැහනේ. මං කියන්නේ අන්න ඒ වගේ තැන්වලදී එයාගේ රිලේටිව් පොසිෂන් එක දැනගන්න නම් අනිත් අය ගැන දැනගන්න ඕනේ. තේරුණාද? So relative position of data is important. That's why we try to find the relative position of a particular data. Okay. Mama, funny story එකක් නෙවෙයි කිව්වේ. To understand the concept of relative position, I just told you that story. It's a true story, right? Okay. Right. Now, relative position of data can be found as percentiles and quartiles. Okay, percentiles and quartiles, two different things. Percentile means given an observed value x in a data set, x is the p percentile of the data if the percentage of the data that are less than or equal to x is p. The number p is the percentile rank of x. You didn't understand anything, no? Okay, I will explain it. Here you have an example. You have 10 number of data, 3, 4, 5, 6, 7, 8, 9, 10. You need to find the percentile value of 3.33. What the percentile is the value 3.33. How can you find the percentile value? 3.33. Before finding the percentile value, you have to rearrange the data set. Rearrange the data set in ascending order or descending order. Okay. If you rearrange the data set in ascending order, then it's easy to pick the percentile value. 3.33. Let's find that percentile value like this. Okay. So we rearrange our data. Now we need to find percentile value 3.33. Now count the number of elements in the data set. Altogether we have 10 elements. Now count 1, 2, 3, 4, 5, 6, 7, 8. So the eighth number is 3.33. Therefore, we find the percentile value like this. 3.33 is the eighth value now. 8 upon 10. Out of 10 elements, 8 value is the value 3.33 and multiplied by 100 to get the percentage. 80. Okay, that means 80th percentile is 3.33. Okay, which means there are 8 values that are less than or equal to this value 3.33. Understand? 8 values upon 10 are less than or equal to 3.33. Therefore, we say 80th percentile value is 3.33. 80th percentile value. Understand? So, if you want to find the 10th percentile value, that should be first one, no? That should be first one, that is 1.39. Actually, that is the second question. What percentile is the value 1.39? So, give me a second, students. Students have come to this lecture room, maybe for a lecture. Please give me a second, I will ask them why they have come.
Recording stopped.
Okay, there's another lecture in this lecture room. That's why they have come. Sorry for the inconvenience caused. Let's resume the
Recording in
lecture.
progress.
Okay. So if you want to find the percentile value of 1.39, we need to pick the value 1.39. And there's only one point less than or equal to this point. What is that? Only 1.39. That means only one value less than or equal to that 1.39. Therefore, 1 over 10 times 100. So, you will get 10th percentile value. That is the first value. Okay? Is that clear, guys? Okay. Are you clear about how to find the percentile value? Yes or no? Please tell me. It's really easy. What you need to do is you need to find that or pick that value first, okay, and count how many numbers or how many elements in the data set that are less than or equal to the given value. Then divide that value by total number of elements in the data set and multiply it by 100 to find the percentile value. So we call that percentile value as the percentile rank of X. Clear? Percentile value of X. Now there's another measure to find the relative position of data, that is quartiles. So I will teach you how to find quartiles here. Quartiles. So if we have a distribution or data set, you know, this is called relative frequency histogram, right? So if we have such a distribution, we know that it's a bell-shaped curve. That means it's normal and it is symmetric about its mean, median, and mode. If you can remember, we considered one measure of central tendency called median, right? That cuts the data into two equal parts, two equal sets, right? Median. Therefore, definitely the median should lie here, median. Because that median should cut the data set into two equal parts if it is median. That's why we call it as mid value. It splits the data in a half, right? Okay, now consider first portion and the second portion. First half, right? In the first half, again find the mid value or the median for the first half. First half. Again find the median value. That median value should cut the first half into two equal parts. Therefore, out from the entire region, that Q1 should cut the data into this 25% and this 75%. Is that clear, guys? That is the mid value. Q1 is the mid value of the first half. This Q3 is the mid value of the second half. Mid value of not third, second half. Q1 is the mid value of the first half. Q2 is what? That is the mid value of the entire region, or the mid value of the entire data set, or the median. So we name these three measures as quartiles: first quartile, second quartile, third quartile. Okay, first quartile, second quartile, third quartile. So by these three quartiles, it divides the entire region or the entire distribution or the entire data set into four equal parts. Four equal parts. Understand? By all three elements, by all three measures, or by all three quarters. First quartile, second quartile, and third quartile. So here we have 25%, 25%, 25%, 25%. So Q2 is the median value of the distribution or the median value of the data set. Q1 is the mid value or the median value of the first half. Q3 is the median value of the second half. Understand? So I will give you the formula to find Q1, Q2, and Q3. Quartiles. Here I have given you a small note for any data set. The second quartile, Q2, that is actually median of a data set median. Okay, data set is its median. Define two subsets. The lower set, all observations that are strictly less than Q2. That means first half. The upper set means all observations that are strictly greater than Q2. That means second half. Because I told you, median splits the data in a half. නේද? භාගයකටනේ බෙදන්නේ. නම් පළවෙනි භාගයේ mid value එක තමයි Q1, දෙවෙනි භාගයේ mid value එක තමයි Q3. Upper set. The third quartile of Q3 of the data set is the median of the upper set. Okay. Example 2. Consider the data set of GPAs given in previous example. Find the quartiles of the data set. You need to find the quartiles of the data set previously used. So here I have given you the same data list. Okay, same GPA. Here also you have to rearrange the data. Rearrange the data in ascending or descending order. So if you want to find the median value, you have to rearrange the data. If you want to find the minimum and maximum value, you want to rearrange the data. If you want to find quartiles values, you want to rearrange the data. If you want to find the percentile values, again you need to rearrange the data in ascending or descending order. Then only you can easily pick those measures. Is that clear, guys? Right. Now let's find Q1 first. Not Q. Here I have found the Q2. But let's find Q1. First we need to find Q1. If you can remember, Q1, here it is 25%. That means 1/4. First quartile. Therefore, we write the formula as n plus 1 divided by 4. That is the place where Q1 lies. Okay. So, n plus 1 divided by 4. That is the formula. Okay. So, for this data set, we have only 10 elements now. Therefore, substitute 10 plus 1 divided by 4. That is 2.75. 11 by 4. 11 by 4 is 2.75. Now, 2.75 is not the Q1. That is the that is where the Q1, that means first quartile, lies. Okay? Therefore, you need to find that place from the data list, 2.75. Now tell me how we are going to find that place, 2.75. Definitely it should lie in between second term and third term because it is 2.75 now. Therefore, pick the second term first, then add 0.75. Now 0.75 is what? The decimal place of this place, 0.75. 0.75 times, now I told you this place should be in between second and third term. Therefore, we get the difference of third and second term. That is third term minus second term. So second term is 1.76. If you can see that value from the list, 1.76 plus 0.75 times 1.9 third term minus 1.76. So get the difference and multiply that difference by 1.76. Okay, and add that difference to 1.76 plus 0.105. Okay, finally you will get 1.865 as the first quartile. Okay, likewise you can find Q2. Q2 is what? Q2 is actually the median. So if we write the formula, that should be n plus 1 times 2/4. But you know 2 over 4 gives half, no? Therefore, n plus 1 divided by 2 is the uh, place of the median or the second quartile, Q2. Okay, so 10 plus 1 divided by 2, that is 11 by 2, that is 5.5. So that is the place where the median occurs. Therefore, to find 5.5 place, you need to pick fifth value and sixth value and get the average divided by 2. Or you can just write it as fifth value plus sixth value minus fifth value divided by 2. Both are same. මේ දෙකේ difference එක ගන්න දෙකෙන් බෙදලා මේකට එකතු කරත් එකයි. If you simplify this, you will get finally this again, right? 2 times fifth value plus sixth value minus fifth value. Therefore, finally you will get fifth value plus sixth value divided by 2. Therefore, if you get this 5.5 as the place, you should get the average value of fifth and sixth term. Okay, right. Now we found first quartile, second quartile, and third quartile. This is the formula for third quartile, n plus 1 times 3 divided by 4, Q3. For this data set, 3 over 4, 10 plus 1. So finally you would get 8.25. So 8 term plus 9 term minus 8 term. Here we have 0.25 now. So you need to multiply this difference by 0.25. Understand? So if it is not clear, I will write it again. 8 term plus 0.25 times 9 term minus 8 term. That is gives third quartile. Okay, right. So next day we will discuss how to construct a box plot and interquartile range. We don't have enough times as there are some students around here to come to the lecture room. So I'm going to stop the lecture for today. Do you have any questions? Yes or no? If you don't have any question, I'm going to stop the lecture. If you have question, please ask questions through an email. Okay. Okay. Thank you for joining the lecture. Have a nice day.
Record